for having me. I'm going to cover a bit about the organisation that I'm part of, which is Safe Landing. My name's Finlay. I'm going to start with a bit of a background to myself, because that's what was asked for, not just because I like talking about myself, but I'm going to give you a little bit of my journey as well, and a background to the organisation, some of our positions on this, and how we're approaching the really difficult problem of aviation industry decarbonisation from a worker perspective, and why we think that that leads to an important position that we need to take, which is there should be limits on the growth of air traffic, and it's really important to consider that from a jobs perspective and a career first, employment first perspective, as well as an environmental perspective. So just a disclaimer that I want to put on this before I start anything. I would tell you, don't trust anything I say. Our group presents like quite an alternative position to the status quo that you will hear from leaders in the industry and in government. So, you know, don't necessarily believe me, don't believe them, but what I'd say is challenge anything that you hear, seek out other sources of information and form your own view on this. But ask any questions, you know, during the talk or later, after the talk, by emailing our email, and I'm very happy to talk through any of this with anybody as well. What I'm going to cover today, I'm going to give a bit about my background, the organisation I'm part of, Safe Landing. I'm going to take a look at some of the issues with aviation decarbonisation plans. Then I'm going to present what our alternative position on the composite view of the future if we do something different is, and think about, okay, well, how can we collectively get there as aviation workers and as concerned citizens of the planet? What are we going to do about it? So just to start with me, I'm Finlay. I'm a mechanical and aerospace engineer. I've co-founded this group called Safe Landing, which is for aviation workers. And before that, I've spent about 8 years working at Rolls-Royce on future aircraft engine design. So I've got a bit of a background on the technical aspects about what's required when designing for better efficiency, etc. So yeah, spent 8 years at Rolls-Royce. Started off on this first flying test bed of a carbon fiber fan blade engine at Rolls-Royce, and then that's me at the front there with the engine on the test bed for the first time. I then moved on to doing architecting the next generation of aircraft engines. So this is even bigger again, really high bypass ratio ultrafan engine that has a gearbox in it. That was meant to go to test in 2020 when I was first working on it. It's now on the test bed now in 2023, and it's not had its first run yet. So that kind of shows you how technology can get delayed by quite a few years in the aviation industry, despite our best plans. I've also worked on future concepts. So this is where airframers like Airbus or Boeing come to the aircraft engine manufacturer, and they say, we're designing a new program, a new airframe concept for 10, 15, 20 years time. We want the aircraft engine manufacturers to develop concepts with us and produce bids for these future concept aircraft. So I was in that job. Part of that was looking at the ultrafan, which I was saying is it's this very high bypass ratio engine with a gearbox in the middle that enables a really large fan and a really small turbine that spins a lot faster than the fan. I was also looking at variable pitch fan blades. This is optimizing the angle of attack of all of the fan blades rather than have a static set of fan blades. And that means you can really optimize for big bypass ratio engine the difference between sea level and cruise, and also in descent and climb and stuff. You can have an optimum level, an optimum geometry, which changes your fan pressure ratio and enables these larger bypass ratios. And it can also enable potentially removing the thrust reverser. But yeah, so I've worked on this kind of technology. And what's kind of interesting with the variable pitch fan is Rolls-Royce literally worked on this in the 1980s and haven't worked on it since. And so why aren't we working on technology like that? Because there really wasn't that much resource going towards these advanced, more radical future concepts. Now, a new engine development, a new aircraft development takes at least 15 years. And this is also like not a radical concept. This is like a relatively incremental improvement aircraft concept. So it takes about 2 to 3 years to architect it, 2 to 3 years to do the rig testing of individual sub-elements of the system. Then you do about 5 years of demonstrator testing, trying, probably breaking and failing things before you get to your final design. And then once you have that, you then take about 5 years to do all the certification testing, bird testing, water and ice, fan blade off, all of the performance testing, all of the life cycle testing takes about 5 years. So at the end of that, you're well past 15 years easily. So the climate and ecological emergency is a this decade issue. We could literally blow our budget for 1.5 degrees C in the next 10 years. So we don't have time even to do this. We should really be working on this as rapidly as possible, trying to minimize this time to get some new concepts in service, but we're not. So why not? What I kind of realized as well is that, you know, to go to the next step change of aircraft performance, you go to something called the open rotor. That gives you a significant step change, maybe like 20, 30% of fuel burn. It enables a really high bypass ratio, which is more aerodynamically efficient. But this concept has flown in the 1980s. It was developed and it's flown, and then it was discontinued in the 1990s. So why was that? Partly it's because there was technical challenges to do with noise and to do with the fan blade off, but those are solvable, right? And we're working on them again now. The big thing was that in the 1970s, 1980s, there was something called the OPEC oil crisis, where lots of countries in the Middle East conspired to reduce the production of oil, and this sent the oil price really high. And it meant that lots of things happened, like in the US, like there was a speed limit on the roads, and there was suddenly development of wind turbine and solar panels, and we were developing these radical aircraft concepts. What then happened across the 1980s was then the crisis ended, the oil price fell, and a lot of these technology projects were dropped. So you can see the oil price and a low oil price really like hinders innovation. Then what happened in the early 2000s is climate change got back on the political agenda. We had Al Gore going to get into the US presidential election, was talking about climate change as a really big issue. And that's when Airbus began their hydrogen studies in the early 2000s, which was kind of interesting. So we had then 10 years later, Airbus studied hydrogen aircraft for 10 years and developed this thing called the cryoplane. And in 2010, they announced we're dropping it, too many technical challenges, it's not going to work, and we're going to just focus on scaling biofuels for the next decade, which didn't really happen either. But that's what they're saying there in the article. 10 years later, we're now announcing hydrogen aircraft again as a new concept. Why is that? It's because climate change is back on the agenda, because a lot of things that happened over the last few years with climate activism and citizen-led movements forcing politicians to think about this. And also in 2020, Airbus were very keen on COVID bailout money and really wanted to show that they were going to do something sustainable to justify all of that public money being spent. So yeah, I think this is really crucial. Environmental activism. So mid-2019, in the UK, Extinction Rebellion took to the streets and shut a lot of streets down in London. And suddenly all of the papers were talking about this. The UK government declared a climate emergency for the first time, and they updated their decarbonisation plans. Also, we had Greta Thunberg kind of became famous. She famously sailed across the Atlantic to go to one of the COP summits. And this meant there was a lot of stories in the media about maybe we should be flying less. That put a lot of pressure on the aviation industry, and kind of at the Paris Air Show, mid-2019, all of the aviation companies, my company included, got together to announce this joint statement on sustainability strategy that basically said, aviation isn't a big part of the problem. Technology is going to save us. You don't need to regulate us. We've got this in hand. And I looked at this statement and I thought, I disagree with the majority of this. I think it's misleading. And I'm not comfortable with my company saying this in public. And I think that these regulations are needed. I don't think technology is going to save us. And I think this is going to have a massive impact to our company, and we should be very clear and honest about what's required, because that's going to suit us, is going to do us best in the long run. So I formed this employee sustainability group within the company. We looked at the different aspects of the sustainability strategy. We got the corporate sustainability team in and discussed this and took them through what we were finding, and asked them, tell us why we're wrong about these things, because it seems like a lot of the strategy is flawed, and this is heading our company and our industry towards a big disaster. So yeah, and then after doing this for a bit, COVID-19 happened, and I took the opportunity to leave the company and just take on climate campaigning, but was very keen to utilize all of the experience I'd gained in the aviation sector. Really passionate about aviation, and I think it's a great case study in a sector that needs to change, is of benefit to the world, but also has a lot of negative side effects. And we really need to tackle aviation if we're going to tackle everything else. And I'll kind of talk through that. So I met a bunch of other workers. Some of them were pilots, air traffic controllers, that were all concerned about climate change. And we formed this group called Safe Landing. This is our website, this is our email address. And we are pushing for a sustainable future of air travel, a genuinely sustainable future that puts the environment first, and it puts jobs first, and it's worker-led. You can find us on LinkedIn, Twitter, Facebook, Instagram. I'm going to share this pack afterwards, so you can follow these links and follow us on social media. And we're very much a worker-led movement. We want to get as many worker perspectives and voices into the conversation as possible. So we're really keen for people to come along to our group meetings and contribute to stuff and help us develop our positions on different topics. These are our current demands that we've generated collectively. So we demand that our leaders be honest about the total environmental impact of flying, be realistic about the limits of technology to solve this problem, be transparent about what future regulations are required to reduce emissions, and have a plan that accounts for this and supports workers during whatever transition is then necessary. And that's not necessarily a transition to something out of sector, it's the transition of the aviation sector itself, and the nature of work changing, and the skills, etc., that are required for that. So our positions, we believe that flying does have a high environmental impact and is currently highly inequitable, i.e. a lot of rich people fly. It has a lot of benefits to high income, high emitters, and a lot of impacts to low income, low emitters that never fly. This is really important because addressing inequity is a crucial part of the Paris Agreement. Technology will not be available at scale in the time required. So we have 10, 15 years, possibly less than 10 years. And all of the technological solutions just simply will not be ready at any sort of significant scale in that timeline. And we need to acknowledge that and then think, okay, what do we do instead? Future regulations are vital, and this includes constraining air traffic capacity in order to reduce emissions. And then we should acknowledge this and then plan for this, because that's in all of our best interests: society, the natural world, and aviation workers. Okay, so this is quite a kind of provocative slide. We're saying that aviation's heading for a crash landing. We really want workers to treat this like the emergency it is, and understand things can't continue as they are, and if they do, there will be really bad consequences for all of us and for the industry. So just on timescales, if we imagine the atmosphere is like a bucket, and whenever we put fossil fuels into the bucket, we're filling it up. And if we fill up that bucket to the brim, we blow our carbon budget, we exceed 1.5 degrees of global warming. Irreversible climate change is potentially upon us. So we've obviously been putting carbon into the atmosphere since the Industrial Revolution, and every year we've been basically increasing the flow rate of emissions into the atmosphere. It's getting faster and faster, and we've now got only 8% of that budget left, less than 10 years. And that was back in 2020, so we're potentially down lower. That's the timescales that we have, less than 10 years. So this is an emergency. This is not a case of, well, we can wait 20 years to scale up hydrogen or wait another 20 years for a new aircraft. We need to act. We needed to act 20 years ago. We can't wait another 5 years. It's such an urgent issue, and we really need to treat it like we're seeing the fire warning light in the cockpit. We don't just ignore it. We focus on it. We deal with it, and we create a plan with multiple options of addressing this. So I just want to take you through, just to kind of emphasize this. We've got various sources that all show we're going to blow the budget. This one's the International Council on Clean Transport. They've got 3 or 4 different pathways of technology. The breakthrough technologies, like the impossible one to achieve, massive SAF ramp up, massive hydrogen aircraft use, etc. All of these technologies, they all blow the budget for 1.5 degrees C by about the 2030s. So there's very little difference between technology outcomes in 2030. We blow the budget in all cases for 1.5. And best case scenario, without constraining air traffic, we end up at between 1.7 and 1.8 degrees C. More likely, we end up above 2 degrees. Transport environment, they're saying flying less offers the best path to sustainable aviation. This is the IPCC. They're saying unless there are immediate and deep emission reductions across all sectors, 1.5 degrees C is beyond reach. Across all sectors is really important. We tend to think maybe aviation can get a free pass. It can't, because there's no room in any of the other budgets in any of the other sectors. They particularly highlight demand management to bring down emissions. They reckon like almost half of emission reductions need to come from this. They highlight active transport, public transport, but also particularly reducing air travel in there. The International Energy Agency, net zero by 2050. This was a massive report that came out in the past couple of years. They're saying that regional flights should go to high-speed rail, and business and long-haul leisure flights should not exceed 2019 levels, i.e. there can be no growth of long-haul air travel beyond what we're doing already. Again, UN emissions gap report, they highlight that reducing long-haul flights has a strong potential to reduce emissions in an equitable manner. I could go on. So what do we mean by equitable? I'm going to cover that first, because I came to one of these talks a few weeks ago, and it was kind of claimed that we need to keep on flying because that's really important for social justice and for developing economies, and because of how important air travel and tourism is for the economy. So let's just address that now. What do I mean by equity? So this is really important. We can't reduce emissions without targeting high income, high emitters. Why is that? It's because the top 10% of income in the world are responsible for basically half of all the emissions. Then the poorest 50% are only responsible for 10%. And then the middle 40% is from the middle 40% of incomes. So you can see there's this massive skew towards these people. And basically, if we don't address them, we can't address the climate crisis. It's very difficult to reduce emissions from the poorest people in the world because they're barely responsible for any emissions, and they don't have the capacity to do it either. So addressing large inequalities in carbon emissions is necessary to tackle climate change. It's just a mathematical necessity. If you look at the US, you can see the top 10% produce much more emissions per person than the middle 40 or the bottom 50%. So if you look at the fact we need to halve emissions by 2030, the bottom 50% don't really need to do much. We need about half emissions from the middle 40, but we need about 90% reduction from the top 10%. This is just like mathematically what's required. And this repeats itself. And this is the US, this is France, this is India, this is China. You can see the top 10% in every country need to take the most action. Obviously, in India and China, it's a bit less. Some of their bottom percent can increase their emissions because it's so low. But in general, we need to target these high income, high emitters. The top 1% is even worse. We basically need to get down to 2 tons per person by 2030. And that's being blown massively by the top 1%. And obviously, if you fly one long haul flight, you can burn 2 tons of CO2 and blow your budget for the year. If you look at the breakdown of where those emissions are coming from, the top 1% there in the EU, a lot of that's coming from air travel, and the top 10% is a big chunk from air travel. But the bottom 90% are virtually responsible for no aviation emissions. So in order to cut these people's budget down, we need to like reduce car use and meat consumption and stuff. But air travel is a massive lever there. So yeah, inequality of flying is really important. 1% of the population produce 50% of aviation emissions. 80% of the world have never been on an aircraft before. Now you could say, well, actually, that's a bit unfair. Like what we need to do is we need to expand aviation so that everyone in the world has access to air travel rather than limit it any further. So is aviation expansion a matter of social justice? I think this is really important before we get into any of the technology stuff. So our position is air traffic growth can provide economic benefits. Obviously, being able to travel, being able to have tourists come in and out is good for the economy. However, aviation emissions also provide these massive climate risks. This is ecological, but it's also social. We might see mass migration, conflict, and economic risks, particularly if there's drought impacting crops, impacting water and food scarcity. There's huge economic impacts from storms and from severe weather events. Low-income countries face the highest risks, whereas it's high-income countries that fly the most. Air traffic growth is only socially just in the context of reducing aviation emissions and impacts. So it's all very well flying to places to improve economics, but if the emissions are going up and causing much bigger damage, then it's clearly not socially just. So if air traffic does grow in some countries, for example, in Africa, where they fly a lot less, that necessitates that we fly less in global north countries, North America, Europe, China, etc., where we fly already far more than the global average in order to achieve that. So if you think it's a matter of social justice, you probably should be against like a 3rd runway at Heathrow or expanding Los Angeles airport. Just to kind of recap on this as well, 1/3 of Pakistan was underwater last year. That caused billions and billions of damage. So we have to recognize that climate crisis has these massive economic impacts as well. And it's not in 2050, it's today, it's already. And this is a big injustice. So we can only say that aviation is providing social impacts if we reduce emissions. So what are we doing with emissions? Well, this is the last 50 years of aviation emissions, and CO2 has just been increasing almost exponentially. And what we're saying as Safe Landing is this is going in the wrong direction. Our industry's on a dangerous trajectory, and we need to set a new flight path. We need to grab the controls and we need to move this in a different direction. However, the industry doesn't want to do that. It justifies this continued expansion using what we call a sustainability playbook of narratives that it uses to justify the growth. And it kind of starts off like this. Firstly, play down the size of the problem. You probably heard this a lot, right? Like aviation is only 3% of CO2 emissions. Firstly, 3% is a massive amount of emissions. It's more than the entire country of United Kingdom, of Mexico, of Brazil. And the other thing is it's on this growth trajectory. So it's estimated that by 2050, aviation will consume 1/4 of the CO2 budget because other sectors are decarbonising. This also, though, ignores the non-CO2 emissions, which are estimated to be 2/3 of aviation's total climate impact. So if you look at that budget, we've got less than 10 years, maybe you need to reduce that to 3 years because we're not dealing with the impact of contrails, NOx, etc., that are also causing global warming. There is things we can do in the short term to mitigate these, but we're currently not doing them. So we probably should reduce the budget further. So next, we then get on to kind of techno and policy solutions that the industry is claiming will solve the problem. First of these is efficiency improvements, then there's zero emissions aircraft, then we've got sustainable aviation fuels, and then we've got carbon offsetting. So I'm going to go through these one at a time. The first one, efficiency improvements. This is what I was working on. So we basically have been improving the efficiency of engines. This is the last 50 years. This is kilograms of CO2 per kilometer, and that's been coming down with time, although it's been getting harder and harder to get those efficiency gains. Air traffic growth, trillion passenger kilometers, though, has been on this exponential increase, 5 to 8% per year, past 10 years. And that has led to CO2 growth of 4 to 5% per year. So basically, air traffic growth is dictating this. Efficiency improvements, you could argue, are abating some of those emissions, but actually you're making it cheaper to fly. And what we find is the Jevons paradox means that it becomes more efficient, cheaper to fly, and people fly more, and actually you increase emissions more. Aircraft efficiency has historically led to emissions increasing and not decreasing. So just by logic, this will continue into the future unless we constrain air traffic growth. Just to make a point here, we should be producing the most efficient aircraft we can do, but my company was working on supersonic with Boom, and yeah, supersonic can consume 5 times to 7 times the amount of fuel that subsonic does. So we're not even going in the right direction of producing and putting our engineers to best effort, like working on more efficient, slower aircraft. We're literally designing more inefficient aircraft that can transport a very tiny elite minority of people using far more electric flight. This is only viable for small aircraft flying very short distances in the near term. Think kind of 10 to 20 people traveling 1 to 2 hours at most. Often, at those distances, ground transport is a more efficient use of green electricity, unless there is mountains, water in the way. So in some cases it makes sense, but it's just not going to eat into the main markets that aviation operates in. This is because batteries and electric motors are really heavy, and the other electrical power systems. 1 kilogram of fuel kind of equates to 25 kilograms of batteries. It's actually more like 50 kilograms, but then an electric motor is more efficient, so you cut that down. But yeah, so your weight and volume is a massive disadvantage. Also, the fact that you discharge a battery and the weight stays with jet fuel, you burn your jet fuel off, the aircraft becomes more efficient. So there's multiple things that mean that electric aircraft are just really constrained in what they're going to be able to do in the short term. We're going to see some small aircraft, but they're not going to reduce aviation emissions. Now, the absolute worst here is electrical vertical takeoff and landing. This is like, with electric aircraft, the least inefficient way you can fly, but counterproductively, this is the area that's getting the most funding and venture capitalist investment, which we are not particularly big fans of. We think that electric aircraft should be designed for maximum efficiency, more like fixed wing, minimum energy per passenger mile. This doesn't do it. Very inefficient because of the vertical takeoff capability, and then even in forward flight, they're not optimized for maximum aerodynamics. So hydrogen flight, so the hydrogen aircraft tend to look a bit different from conventional aircraft. Now, hydrogen kind of looks good when you look at the mass. It's kind of like where jet fuel is like 50 times better than batteries, hydrogen is like 3 times better than jet fuel on mass, which is good. However, the volume for the same energy, the volume is a quarter of jet fuel. It's a quarter of the energy within the same volume of jet fuel, which means you need 4 times the volume and that's liquid hydrogen that's being compressed to cryogenic temperatures compared to jet fuel. So yeah, if you require 4 times the volume, you end up with an aircraft that is a lot more bulkier than jet fuel. This can kind of mean a couple of things. So it can either mean that you increase the aircraft size and then you increase the drag and the weight of it, and it's less efficient, or you have the same aircraft size, but you get rid of passengers to put in the hydrogen in the fuselage. It can't fit in the wings because of the shape of the tanks. That means you need to redesign the wings, along with the fact you need to redesign the combustion system, means that really we're looking at sort of 15, 20 years before we get anything that's like a similar size to current conventional aircraft. We will see some hydrogen aircraft in the next 10 years, but they're likely to be smaller turboprop regional aircraft. So volume is the big killer. So just in general, likely to be viable for medium aircraft, more likely regional in the short term, flying medium distances, likely to take 15 to 20 years to develop and certify the first aircraft. If we actually go down this route, there's also likely to be issues because it's quite a different technology. We're probably going to get things wrong and that will delay things. Also, it requires very different aircraft, airports, and very large amounts of energy. So, and I'll kind of get onto that when I talk about e-fuels, because the amount of renewable energy that's required is massive. So alternative jet fuels, sustainable aviation fuel, you see these called. The idea is that rather than extracting carbon from fossil fuels that are stored deep underground, that's then emitted into the atmosphere, increasing global warming when you burn them. We're going to take carbon that's already in the atmosphere, either in biofuel, biomass, or we get water, we electrolyze that to hydrogen, or we capture carbon from the air and combine those things together using renewable energy, and we've got a kind of closed loop system. Now, just kind of getting into these things, it's worth noting we've been talking about this for decades already. Back in 2008, we promised there would be 10% alternative fuels by 2017. And that target has been revised down as we go. And we're now looking, the EU just announced a mandate for 6% by 2030, which is obviously not a big amount. And these things aren't necessarily environmental either. So let's just take a look at them. So biofuels first. This is kind of meant to be a nice closed loop cycle. It's all green and natural, the circle of life. And I say, actually, this is the circle of strife. So there's biofuels are very dangerous, and it's really important that we're critical of these as aviation workers, and we critique the sustainability of some of these feedstocks. Fuel from crops, so this is rapeseed, soy, particularly palm oil, have emissions that are actually much higher than fossil fuels. Because there's land use change, it leads to deforestation, draining peat bogs. The emissions produced are actually worse than fossil fuels. Now, the industry is saying it's not going to produce SAF from fossil fuels. However, we've done some work helping a human rights group in Paraguay, where the biggest SAF refinery is being built in the Southern Hemisphere. It's being built in the Chaco region of Paraguay that's suffering like one of the highest rates of deforestation anywhere in the world. And that's all soy production for cattle, and then waste soy oil and animal fat from the cattle is being used for this sustainable aviation fuel refinery. So yeah, and there's more instances of this around the world where these crops are sneaking in as apparent wastes. So can fuel from waste scale instead? So, you know, we've got like sawdust and bark from forestry. We've got animal byproducts and agricultural waste from farms. Can we use these? But the thing is that there's competing uses for a lot of this stuff, and that's what's really important. And there's only so much waste that's available too. Transport environment say that maybe we could reach like 10% biofuels by 2050. So that's nowhere near the demand that we're expecting. The other thing about those biofuels is there's competing uses. So we need non-fossil fuel fertilizer. We need bioenergy carbon capture and storage for negative emissions and to help the grid balance renewable energy. We need road transport fuels in shipping and trucking, and just cars that aren't going to be able to switch to electric over the next 15, 20 years. There's a lot of liquid fuel that's still required in ground transport, shipping fuels, bioplastics, and there's a real lack of cross-sector analysis to see how much have we got and which other sectors need it. So just thinking about, should it be prioritized for aviation? This is a low, medium, high feedstock availability for biomass. You could see that in the best case scenario of what's available, aviation biofuel could use all of that up, which would mean nothing for anything else. We also have potentially this for bioplastics, and BECCS, bioenergy carbon capture and storage, could use it all as well. So really, we're probably likely to need to use all our sustainable biomass just for bioenergy carbon capture and storage. Negative emissions, because we're going to blow the budget, and then we're going to have nothing available for aviation. Okay, so what about electrofuels? So this is the idea: you've got water, you electrolyze it using renewable electricity, and you get hydrogen. You then power direct air capture, and you combine hydrogen with carbon, and you get a liquid hydrocarbon. Burn that in the aircraft, that emits CO2, and you recapture it again in this cycle. Of course, you don't recapture the non-CO2 emissions. So the thing about this is just how ridiculously energy intensive it is. So this is a calculation I did. I've hidden the slide, but I'll share the pack and you can look at my calculation if you want. I worked out that for current jet fuel use in the UK, we'd need an offshore wind farm the size of Northern Ireland, 135 kilometres across. And this is in comparison to the existing wind sites around the UK at the moment, just to produce jet fuel for the UK aviation industry without any growth. So why is this? So basically, we used 12 million tonnes of jet fuel in the UK in 2018. To produce that in e-fuel, basically that's about 140, 50 terawatt hours. And the e-fuel process is quite inefficient. I've used a 45% efficiency, so you need, which is about in the middle, so you need 300 and something terawatt hours. Now that might not mean much to you, but the current grid generation capacity in the UK for everything is 330 terawatt hours. So it's basically you'd need the entire grid. And renewable generation in that is 110. So you need 3 times renewable generation just for aviation without any growth. Now, the problem is just taking a step back and looking at total human energy use. And this is what it was in 2019. We've got biomass, coal, oil, gas, and then nuclear is the tiny red bit. Wind and solar is like 1% and 2% each. So we're far, far away from decarbonising existing energy use with renewables. It feels like we've got a lot of renewable growth, but we're so far off. And what we will do if we add these energy intensive processes is we will just extend how long it takes to get off of fossil fuels. So we've got a finite supply of renewables, and if we increase our energy consumption, we'll just burn more fossil fuels. So it's really important we don't waste our renewable energy with inefficient activities. This is a chart from Committee on Climate Change. It shows if you've got 1 megawatt hour of low carbon power, what you should prioritize it in to maximize your CO2 savings. So it says displace coal or gas on the grid, power an electric vehicle to displace petrol or diesel, power a heat pump to displace gas in the house, power direct air capture, and then the worst thing you can do is like produce hydrogen or produce synthetic e-fuel. In fact, you're far better just burning kerosene and doing negative emissions than producing e-fuel. And that's because of how inefficient it is to make hydrogen. So basically, the crunch here is that producing e-fuel is like the least efficient method of using renewable energy. So really, we should not prioritize it. So final thing on this list, carbon offsetting. I think you all know what this is. It's saying I'm going to keep on increasing my emissions, but I'm going to pay somebody else, usually in the global south, to reduce theirs. Now, before I can even get into this, just say I think carbon offsetting is fundamentally flawed. This is admitted by the sector. The CEO of United Airlines has said, even if we covered the entire planet in trees, this would only offset 5 months of current emissions. And then we'd have no land left for human habitation, for biodiversity, and for farming our food. So we just simply, there's not enough space on the planet to do this. Yeah, so there's a couple of schemes. There's the ETS, emissions trading scheme in the EU, in the UK now. Problem with this as well is that there's just free allowances for all of the airlines. So a lot of the airlines don't actually pay that much. However, that in turn is actually quite a lot better than this international carbon offsetting and reduction scheme for international aviation, or CORSIA. This is a really weak policy that covers international aviation emissions, which are the majority of aviation emissions. And the problem with this is that it only offsets emissions. Offsetting doesn't work anyway, but it only applies to emissions beyond 2019 levels. So obviously we've had COVID the past few years, and we've not even been above that level, so nothing's being paid for. And then after that, it's only emissions that are above that level that are offset, nothing below. So most CO2 emissions aren't covered. And then non-CO2 emissions, which are 2/3 of the climate impact, aren't accounted for at all within either of those schemes. So the majority of emissions are going unpriced. Those prices themselves are super low, less than $10 per ton of CO2, whereas carbon capture costs more like $1,000 at the moment. So the real cost of industrial carbon capture is far higher, and it's just not being paid for. So this is going to have to change. So basically offsetting too weak and doesn't apply to most emissions, and it's just ineffective. Just a bit on negative emissions. Super high risk as well, very energy intensive, relying on biomass or relying on renewable electricity again. And we just don't have the resource for this either. But either way, they're going to be very, very expensive, and this is going to have an impact on the cost of flying, and therefore how we need to change how we fly. I'm going to skip through this. So what I think we need to do, challenge false solutions like this, greenwash, and say what it is, demand real solutions instead, so policies, form citizen-led and worker-led movements to push for those policies, and prepare ourselves for change, adaptation. So what policies do we think are required? So safe landing opinion. I think all the aviation emissions should be accounted for in these NDCs that are submitted to the UN. That should include international as well as domestic emissions. It should include non-CO2 as well as CO2. We need to allocate, this is like a budget problem. We need to allocate a budget to each country, to aviation in each country, and then allocate that nationally between airports and airlines so that we know that we're operating within a safe budget. There's probably going to need to be pricing of emissions, like a jet fuel tax. We need a clear roadmap of how that price is going to increase over the next few decades, and it needs to be a realistic number that is proportional to the cost of negative emissions and hydrogen and sustainable aviation fuel. We need progressive policies, ideally, like frequent flyer levy that improves the equity of that. So it means higher income, higher emitter, frequent flyers pay more. Technology. If there's more pricing, there's probably going to be more rapid development of efficient aircraft, phasing out of older aircraft. Aircraft and air transport networks should be designed for minimum energy use and fuel burn. Probably going to be flying less fast, less far, less frequently. Fuels, probably think there should be low use of aviation biofuels, no bioenergy from crops, and bioenergy from waste probably needs to be prioritized for fertilizer and other uses. Low use of e-fuel and green hydrogen for aviation probably needs to be unsubsidized, so that we don't waste all our energy on that, which means e-fuels and hydrogen are going to be very high cost. And it's likely we'll have to pay like a cost premium for those to discourage really inefficient energy use. So all of those things are pointing to the cost of flying increasing. We can also improve the quality of kerosene to reduce health impacts and reduce contrails. And it's quite likely we should maybe just do that, burn higher quality kerosene, and then pay the price for direct air capture. Offsets should really be a mitigation, not a solution that neutralizes emissions. And we're going to need to limit air traffic in high emitting countries that already fly more than the rest of the world. Yeah, so this kind of thing around optimizing for minimum energy use and flying less fast, less far, and less frequently. There's been often a lot of studies that show that you can fly slower. And if the fuel price was higher, we would do this. We would produce more efficient aircraft that are designed for a lower optimum Mach number, which means we could save a significant percentage of fuel burn just from flying slower. But airlines don't really want to do that. Yeah, so we think, new aircraft like electric and hydrogen probably will be developed more rapidly, and that will mean aircraft will have smaller capacities and ranges because of the volume and weight of batteries and hydrogen. So maybe we need less centralized mega hub airports and more local smaller airports that have a more distributed network that allow more people access to travel, but less frequent flyers that are flying really long distances and using up all of the budget. Possibly hydrogen, e-fuel production near airports, and more sustainable long-term jobs because of all this change that's required to change the industry and transform it, and fly these slower aircraft with less people in them. So I'm just thinking at the time, it's got less than 10 minutes left. So I'm going to kind of skip through some of this stuff, but basically in the pack that I share, you can go through some of these assumptions in more detail. But we see this modal shift happening that I was talking about there. And just thinking about airports of the future being designed for different aircraft and what's going to happen with the jobs. So the point that we're making here is that fossil fuel companies' profits need to reduce, but that aviation workers won't. There's lots of work to be done transforming the sector and transforming the way that we travel to fly slower and less far. So lots of work to be done. The challenge is huge. So we need increased numbers of pilots, cabin crew and stuff for smaller, slower aircraft. We need to design and develop lots of new aircraft and engine technology. We need to redesign airports. And we need new training for those jobs as well. And obviously, and higher quality tourism can go hand in hand with this. Just as an example, if there's less long haul flights, but there's more smaller aircraft flying shorter distances, even though air miles will be reducing, there could be a balancing effect on employment with increased number of aircraft, but they're smaller, and the length of flights, because we're flying slower. So basically, there might need to be more employees. Airlines don't like that because the cost of flying goes up. That's bad for profit margins, but it's good for employment, and it's also good for limiting air transport emissions. Maybe we need to, for long haul flights, cut them in 2 or 3, so they're doing smaller hops. But again, that then means more employment time at those airports, etc. Yeah, obviously, if we need to get rid of passengers to fit in hydrogen, that means that we need one pilot for less passengers. So to transport the same number of people, you're going to need more employment as well. So there's potential employment rebound benefits of this stuff, along with designing new aircraft and redesigning airports. And yeah, so tourism. So part of this is improving tourism and is actually like enabling us to still have places in the world that we can travel to, and we're not going to destroy some of our major tourist attractions like the Great Barrier Reef. So along with like less traveling in terms of distance and speed, we can also like think about the negative consequences of over-tourism and how we can change the way we travel and also change tourism at the same time. So there's a clear opportunity to both reduce negative over-tourism and also improve responsible tourism, which can give positive economic, environmental, and social impacts. There's already good examples of that, where reduced quantity of tourism can increase the quality. So resetting aviation can help reset the tourism industry as well, we think. So just a worker critique to finish this off on sustainability plans. So this is from ATAG. This is you might have seen this kind of roadmap of our emissions are going to increase, but we're going to reduce those with technology and efficiency and sustainable aviation fuel. But there's still this area under the curve of emissions that are going into the atmosphere. And if we redraw this, you can see that we're going to blow our budget for 1.5 degrees C unless we reduce to zero by about the mid-2030s and go straight down there immediately. If we don't just continue as the industry is planning, we're going to overrun the budget for 1.5 by a massive amount. So what we think is going to happen in that case is flying will suddenly become a lot more expensive. There'll suddenly need to be limits on air traffic that's enforced, and this could be really bad for workers. Think about it, we've had historic growth. We've then had a COVID-19 crash. The industry is now wanting to return to pre-growth, pre-COVID growth trajectory like this. We're saying there could then be a massive climate crash, at which point we might be able to rebuild the industry if, if there's still a habitable planet to live on. What we're saying is, how about we minimize, how about we're sensible about what we do in the short term in order to extend that budget for as long as possible, to enable a transition and to allow that to be as smooth and as planned as possible. Obviously, we've had unjust transitions in the past where industries are closed overnight, workers have to fend for themselves. We think that any transition should be up by early design rather than late disaster, with workers always losing out. And we need to make ourselves future fit for the future and right size to minimize the need for workers to transition out of sector. So if we go and double the number of aircraft and double the number of people to operate them, and then suddenly we need to half the number of flights, there's going to be a lot of people with job losses versus if we're more careful with how we expand. We need workers being informed, consulted, and having their needs recognized, and they also need support to change. The thing that we're noticing, though, is that business leaders don't want to have this discussion. So our analysis is that in a couple of years' time, business leaders will have left the industry, they'll taken their retirement package, but the climate crisis is a 10-year problem. Workers want to have a career for decades. So we've got a very different time horizon, and we have very different priorities from business leaders. So what we're advocating for within Safe Landing is, some of our positions we've got to based on lots of examining the facts and looking at the evidence. We don't want to push those positions onto trade unions, though. What we're really keen on aviation workers doing and trade unions doing is running climate assemblies where they get in experts to educate themselves and inform themselves about some of these topics and come to consensus decisions about what they think from a worker perspective, and then take those lobby positions to their industry and to government. So we've been pushing for this Workers' Climate Assembly, and we've got a petition for that we launched last year, and we're actively engaging trade unions on that. I'll just skip this. This is our critique of ICAO's net zero. So worker assemblies, we've got, this is this concept of deliberative democracy that's been used for citizens' assemblies. It's something that we're really big on. You can find out more about this on our website. But what we're really looking for people to do is to create a bit of a network of aviation workers that are concerned about this across the world, and will go to their respective trade unions and advocate for this like we're doing in the UK at the moment. So really keen for people to come and join us by going onto our website, filling in this form. You'll get our newsletter, you'll get links to our Telegram groups, and you can come along and join our group activities. So that's all for me. I was asked to do about an hour, so I think I'm going to stop there and allow some questions and answers.